everybody, this is a video about writing polynomial functions. If you haven't watched the video Polynomial Quick Facts, you need to do so because we're going to be using one of the theorems from that video to write this polynomial function. So let's get started. Alright, we need to write a polynomial function of least degree with whole number coefficients, integral coefficients, that has these two numbers as zeros. So we're going to make use of the conjugate pairs theorem and the factor theorem. So I'm just going to say y equals instead of using function notation. If 2 plus the square root of 5 is a 0 of this polynomial, x minus 2 plus the square root of 5 is a factor. That's the factor theorem. Now, from the conjugate pairs theorem, if 2 plus the square root of 5 is a 0, 2 minus the square root of 5 is also a 0. And that means x minus 2 minus square root of 5 is a factor. Now we move on. If negative 3 plus I is a 0, x minus negative 3 plus I is going to be a factor. So x minus negative 3 plus I. That's a factor. And then use the conjugate pairs theorem. X minus, well, if negative 3 plus I is a 0, negative 3 minus I is a 0. Now, this is technically the answer to the question. We've written down a polynomial function, and it has the given zeros. Now, it's implied in the instructions, integral coefficients, that we're supposed to multiply all of this out. Now, that's going to take a little while to do. Sometimes when I give a pre-calculus test, I tell students to leave their answers in factored form, but on homework, sometimes you have to multiply all of this out. It doesn't look like a whole lot of fun, and it's not. I'm actually hoping I have enough room on the screen to do this, just to warn you of some of the algebra involved. I think we'll have plenty of room. It's not as bad as I made it out to be, but it certainly doesn't look fun. So we're going to use the distributive property a couple of times, and I highly suggest when you're doing this that you write this down exactly like I am. So for example, when I wrote this, you may be tempted to use the distributive property to distribute the negatives. I would not do that if I were you. In my experience, that just causes trouble. All right, so let's start following these arrows. So the top arrows, we have x times x. Whoops, let me erase that little stray mark. We have x times x, which is x squared. Now we have x times this factor, this 0, and this is negative. I suggest writing that minus x and then 2 minus root 5. Don't try to distribute in your head. In fact, at the next step, I don't think I'm going to distribute at all. Now, go to the bottom arrows. We have negative x times this 0. So it's negative x times 2 plus root 5. And now for the last arrow, negative times negative. This is going to be positive. Now, once you're comfortable with this, you can actually multiply these conjugates in your head pretty easily. I'm not going to do so on video because it's an instructional video, but you are welcome to multiply those out in your head if you want. All right, now let's go to the next two factors with the complex numbers. X times x is x squared minus x times negative 3 minus I, and then minus x times negative 3 plus I. Again, once you're comfortable, multiply the conjugates in your head, but negative times negative, we have plus negative 3 plus I, negative 3 minus I. So that's a lot of stuff. Luckily, at the next step, a lot should cancel. It shouldn't look nearly as bad as you are thinking it might. So let's see. I'm going to get another color here. If you were to distribute, you'd have negative x times 2. So that's negative 2x. But when you distribute here, you have another negative 2x. So that's going to end up being negative 4x, which I'll write down in a minute. If you were to distribute, you have negative x times negative square root 5. So that's positive x square root 5. Here you'd have negative x times positive square root 5. So you'd have negative x square root 5, meaning when you distribute here and here, those cancel. And the same thing's going to happen over here with your imaginary numbers. Here you're going to have plus xi, and here you're going to have minus xi. So those are going to cancel. So let's write down at least a little bit of what we have so far. We have x squared. We have minus 2x minus another 2x. That's minus 4x. The root 5 terms canceled. We had positive x root 5 and minus x root 5. And now we have to deal with these conjugates. Well, the whole idea of multiplying conjugates is when they multiply together, nice stuff happens. So we have 2 times 2 is 4. That's a nice whole number. Now remember what happens with conjugates. We have minus 2 root 5 and plus 2 root 5. Those cancel. That's the whole idea with conjugates. So 2 times 2 is 4. Positive root 5 times negative root 5. That's minus 5. So we have 4 minus 5. 4 minus 5 is negative 1. That's not so bad. Now move to the next big factor. We have x squared. Remember, plus ix minus ix, those canceled. We have plus 3x plus another 3x, so that's plus 6x. And then again, when you multiply complex conjugates, we're going to have plus 3i minus 3i. The imaginary terms cancel. So if you look at what's left, we have negative 3 times negative 3. That's positive 9. And then I times negative I, that's minus I squared. 9 minus I squared. Well, I squared is negative 1, so this is 9 plus 1, which is 10. Now, the next step, you need to keep going. I'm going to stop the video here. At this point, we're really down to just some basic algebra. It would just be time consuming to do. There are 9 arrows to draw. 1, 2, 3, 4, 5, 6, and then 7, 8, 9. So follow all of the arrows and then combine like terms. But like I said, that's not really a pre-calculus problem anymore. I trust that you can do that. So anyway, the key here was using the conjugate pairs theorem and being very careful when you multiply, at least at the first couple of steps before we get down to this relatively simple problem. So that's how you construct this polynomial. Hope it helped.